Itu harus dibilang itu.
Good evening.
Good evening, Doc. How
How
are
are
you?
you?
I'm good. Thank you so much. Hope my screen is visible.
Yes, we can see them.
Okay, thank you so much for your confirmation. Mm,
Thank you.
okay, so welcome back again to the last session of this particular training on data mining using Vika software. So today I have shared one particular data set to you, which is there in the .csv format. Okay, so try to download the data and whatever shared on the group, you may try to download it. So that because till we have not used any .csv data, right? And by default data sets we have used in our all sessions. So today uh, we will consider this .csv data and accordingly we can proceed with that data. Okay, so let me finish at the yesterday's topic firstly. So yesterday we stuck in between some important topics. As today's topic, you can see here some advanced methods and case study along with hands-on project we will consider today. Fine, because this is very important when we learn any new software or tool. So basically, we have to evaluate whether we have correctly learned that or not. So for that purpose, we have given one data to run with a Veka for one particular case study. So from the beginning means from loading the data to applying the classification algorithms, clustering algorithms, and association rules. We will use that data with different approaches. So this in this session, I will just give the advanced data mining techniques and the time series analysis, predictive modeling as well, and then one case study we will do. Before starting the practical and case study, again this topic which we missed yesterday due to some technical reasons, we faced some reasons, and due to that, I have not delivered the content in that particular manner whatever expected. So that is why again I'm considering this one. So clustering, yesterday we saw that like what is exactly clustering is. So simply it is one of the method one of the approach through which we can like group some similar patterns, some similar properties. Okay, and we avoid the dissimilar properties, dissimilar contents, dissimilar objects to group those patterns. Okay, that means, for example, here I have one image, some data is there in the image. Okay, some, for example, here some pens are there, some rubbers are there, erasers are there. Fine. Then notebook is there. Let's consider this notebook. This is the eraser, for example. Again, one pen is here. So my drawing is not good, but just remember this one. This is the pen. This is also one of the pen, and this is the eraser, notebook, and pens. So these three categories are there. Fine. And according to these three categories, I have to categorize, I have to cluster, you can say, or I have to group some similar patterns. Okay, so in this case, we can apply the clustering algorithms, and then we can do the clustering. Means clustering objects, first of all, search for the similar patterns. Okay, this is our data, which is given as an input data, and here on that input data we are trying to applying the clustering algorithms. Fine. So clustering algorithms will not use the label information here, because labels are not there. For example, as we know, this is one of the unsupervised learning approach, right? So in a supervised with the data we have some labels, but with the unsupervised, like a clustering methods, we don't have the labels, or if labels are there, we are not considering those labels. Directly the data we are giving to the algorithm, and in this case, whatever similar patterns are there based on the applied clustering algorithm. So K-means is one of the famous algorithm. Then the second one is the CoWeb, is one of the famous algorithm, and many more algorithms are there. So according to those algorithms, we can perform our methods and data, and then we can get the output. So here, whenever we try to give the data to the clustering algorithms, so it applies some similar patterns. It considers similar patterns. Okay, according to the distances, according to the given instances. Okay, means, for example, in this particular example, three different patterns are there. One pen is there, the second is eraser, third one is the notebook. Okay, so these three are having different properties. They are completely different with each other, right? So algorithm of clustering will cluster those three patterns. For example, cluster one, that is a C1, cluster 2, C2, and cluster 3, C3. And C, remember that here you can see the definition also. Group of objects such that objects in a group will be similar or related. So whatever similar patterns are there with respect to the first group, for example, pain. So similar patterns regarding the pain can be grouped in a first cluster. Then in the second one, the second category, that is erasers. So similar patterns of erasers will be considered as a second cluster, and third one is the notebooks. Okay, so these three are totally different with each other, and definition is clearly saying that group the similar patterns to another and different from the objects in the other groups. So these are the similar patterns. For example, pain can be considered in a one group. Erasers will be considered in the second group. So whatever erasers are there in the data. So here we have taken one sample, but let's consider 30 erasers are there, 20 pens are there, and notebooks are 50. In this case, 50 notebooks will be given in the third group, 20 erasers will be given in the second group. So these all classes are different with each other. So this is nothing but the clustering. Hope so this is clear now. And applications already we have seen, market prediction, segmentation, document clustering, etc. We can apply the clustering algorithms. Now the theory about association rule. This is also very important. Till now we have applied some mathematical algorithms, whatever algorithms like a supervised, unsupervised. In all those cases, the algorithms are like using some mathematics, some statistics to calculate the data, and accordingly they are producing some output. Okay, but here I don't have the numerical information in my data. So in this case, whatever mathematical algorithms are there will not be worked because there is no number, there is no uh, numbers in that case. So in those cases where numbers are not there in the data, we can apply the association rules. Okay, means association rules can be applicable only to the data where numbers are not present. Hope so this is clear. Numbers are not present, or simply you can say it is applicable to the non-numeric data. Non-numeric data. It is applicable to the nominal data, for example. Now, this is one of the approach through which we can check the associations and between different instances, and accordingly we can try to find out the uh, rules. Okay, so those rules can be used for analyzing the particular application or particular objective. So you can see, for example, association rule. This rule is itself saying that, I mean, this particular algorithm itself saying that discovering a relationship between similar independent relation databases. So whatever similar independent databases are there, according to them, we can just make a relationship. Okay, how can we make the relationship? So in a computer science, in some programming languages, we are using if-else statement, if-else conditions, if-else condition, okay, or if-then condition. So here, the same approach of if-then is applied in the association rule to find out the relationship between similar independent databases or other data repositories. Okay, so here you can see association rule is one of the important learning technique which can be used in detecting the dependencies between two atoms. Okay, two atoms, for example, here I am having two atoms, A, I am writing here A, and second one is a B. These two atoms are there. Okay, so association rule, remember that association rules are having two parts. First part is, let's consider here is A, second is a B. That means first part is antecedent. Okay, so this is nothing but the, I am just writing here antecedent, antecedent, and the second one is the consequent. Consequent. Okay, so antecedent means if. First A means if, and B means then. Okay, so in every case we have the two major parts in association rules. Okay, so antecedent is something that that's found in the data, and consequent is an atom that is found in the combination with the A or with the antecedent. Okay, so for example here you can see the data table. Okay, bread, coke, milk are the atoms, Then in the second ID, beer and bread are the items, coke, diaper, milk, etc., etc. Some items are there. Okay, for example, someone is trying to buy these items. So you can see how can we apply these rules, association rules. So let's consider the data here. If one customer or someone is trying to buy this one and he is purchased the bread, he is purchased the bread. That means he will also purchase the milk. Okay, because bread uh, can be bought if the person or the customer is buying the milk, because in normally with the milk, with the milk product we can eat the breads, even though nowadays bread we can eat with the other also, but this is the relation between these two, uh, you can say the set of records. Okay, here we have remember that the part given in the association rule, that is a antecedent and consequent. Means antecedent is if someone is trying to buy bread, then he will likely be trying to buy the milk as well. So that is nothing but the association rule. Okay, okay, rule applied for here. This, you can see here, milk and coke. There is no relation, right? But someone is trying to buy milk. That means in that case might be the person who is trying to buy milk having some children's. Okay, so he will also purchase the diaper as well, or he will also purchase the coke as well, beer as well. So likewise we can apply the uh, association rule algorithm and we can create the association relationship between the uh, different objects. Fine. Hope so. This is clear. So this key, theory we missed in last session. So for example, again, bread. You can see here, bread is antecedent and milk is a consequent. Okay, if someone is simply trying to buy the milk, that means he will likely be try to buy the bread as well. Okay, so there is a relation between these two, and on this particular rule we can just differentiate different characteristics. Okay, fine. So this is the theory regarding the today's session, which we missed in last one. So directly I will show you the demonstration with case study now. Market basket analysis, because someone is, for example, trying to promote their sales. So in that case, self management or inventory management rules can be applied. And even though in a, medical case, for example, if someone is trying to trying to buy some tablet, that means he will also buy some other what we can say, the drinks also. Okay, so that is the case about association rules. Some syrups, or if someone is trying to buy tablets, then he will also try to buy the syrup also. Okay, so likewise the rules can be applied. Any question? Am I audible now? Okay, so uh, I have shared one data with you, right? Just try to open that data. I'm just opening my Weka first of all, and then I will show you the demonstration. Open it. I have shared the data on the WhatsApp group. Just download it and use here. Open a file. Just choose the folder where you have downloaded the data. Now see, the data is there in the .csv format. Okay, .csv format is like a comma separated values. So that is used here, and already we are using the ARFF data. ARFF data is nothing but the aircraft file format. So that data, not aircraft, sorry, attribute relation file format. So that data we are using, but in some cases we will have the other formats also. Okay, so this is one of the format of the data. Just click on this CSV data files, and then open it. Now see here the bank data is present. Click on that bank data. I just click OK. Now the information regarding the bank data is loaded here. Fine. You can see 600 instances are there in the data. Okay. Then 12 attributes are there in the data, and you can see some of the data like ID is there. So count is 111 for all ID. Weight is also 11. Then the age is one of the another pattern of the data. Okay, ID is, as we know, it is one of the unique identification number, right? Then yeah, you can ask the question if you have the question in between. You can interrupt me because today's presentation session is important. Yes, Nilesh, you may unmute yourself and then ask the question, or you can put the question in the question answer.
No question, sir.
Okay,
Before your screen is stuck, that's why I was.
okay, no
Now
problem.
it's clear.
Okay, so unique ID is first column number, that is attribute number. Then second one is the age of the customers, which is given in the years. Okay, so minimum age 18 and maximum age is the 67. So in years the age is given and data is numeric. Okay, can we apply association rule on this data? Can anyone let me know the answer? This whatever data we have loaded right now, can we apply association rule on this data? Getting my question?
I think we need to filter the data first because we have mixed nominal data and numeric data at the same time.
Yeah. So this numeric data is there. We need to convert into nominal format. Then only we can apply the association rule. Okay. So this age, then the male female category, 300 males are there, 300 females are there in this data. Regions are like city, town, in rural, suburban. So according to the different labels, The four regions are there. Income is like a minimum is 5,000 something and 63,000 something. So average income is uh, 70,000, 27,000. Fine. So this information is also numeric. And see, I'm just clicking one by one data because I'm checking the missing values also. Because after this data, we are going to load one real-time data, and that is having near about 35,000 instances and 230 values, 230 attributes. Okay, so that is why I'm just showing the attributes and their parameters. So this is the married attribute. So whether the person is a married or not. Then see the type of this data is a nominal. Okay, so there is no number. Children, again, number of children, minimum 0, maximum 3 childs are there of those employees. Okay, so because we have loaded the bank data, you can see the relation. Bank data is loaded, and some of the employees are there of the bank, or you can say the customers, not employees, customers are there of the bank. Fine. And next one is the car. Again, a nominal data. So car is saying that does the customer own the car or not? Yes or no. Next, the property, next attribute is having the saving account or not. Yes or no, nominal format. Having the current account or not of that customer. Then mortgage, that means the customer have mortgage, yes or no. Okay, and lastly PEP, that means did the customer buy the equity plan, like a personal equity plan, that is PEP, after the last mailing, yes or no. So that type of information is there in the data. Fine. And now on this data, I have to just apply some information, and we have to get some insights from this data. Okay. So this data is, as mentioned, it is present in the .csv format. Fine. Then some of the information is there. So each record in this data for this particular attribute is like a numeric attribute. So it is a unique identify number. So there is no need of this because you can see the numbers and this one. So unique ID is not required in further analysis because the target is that whether the customer or the customer can buy PEP or not. That we have to find out. So in this case, ID is not required. So that is why we need to remove this one. Now just let me know how can I remove this one. How to delete the ID attribute from this data.
Okay. So
Yeah,
you just tick the box on ID and then go down and click.
correct. So just
Then
click on that, and here, whenever we click on the particular attribute, so this button will highlight. So in that case, we can just remove it. Okay, remove it. Now that is the remove. Now total remaining attributes are 11. Okay. Now here some attributes, for example, again I want to remove. So here also you can use the filtering option. Under filtering, you can see unsupervised, supervised filters are there. Sorry. Here also we can apply the remove button, remove option. Okay, unsupervised, and here attributes. You can see here there is a option this option, a remove option. So that removes a range of attributes from the data. Either that simple activity we can do, directly click and remove, or you can directly apply the filter. So in a both way we can do it. So one activity we have done here. Now we can just save this data, or there is one option here you can see here. Yeah, question.
Yes, I'm a bit. I'm behind a bit. What did we remove last year?
I have just removed the first attribute, deleted the first attribute.
Yes,
That is I have done only
yes.
now.
Then next, what? Okay, thank you.
So the removing option we can do through the filtering button also. So here filters as mentioned, under filter we can get the remove option. Okay. Now you can see here, for example, here some options are there. So till time we have seen only the first four, like open file, open URL, open database, and generate. But last three we have not seen in earlier sessions. So undo whatever last activity we have done, we can just undo that activity. Just click on undo and see. I have deleted the ID in my earlier time. So now it has been automatically readjusted because the last activity, whatever we have done, can be restored through the undo as we know. So that is one of the new option we can get here. And if you by mistakenly delete anything or you did any mistake in processing, so in that case undo button we can apply. Hope so you are doing with me. Next button is a edit button. So here we can check the information about the data. You can see here. So whatever values are there in the data, just remember that some columns are there like age, then the category of male female, then the region, income, married status, uh, children status, car, saving account, current account, and other information are there. And see all the information we can just visualize here through this edit button. One more option is there in this particular viewer. So here we can add the instance as well. At the last we can add it. Now see, this new instance has been added. If you want to add some new instances, new rows in the data, so in this case we can apply this one. Okay. So I'm just clicking on undo button because I don't want to add anything here. Click undo and just see the content. Okay. Or you can copy the content, save somewhere. So you will get the idea about the data and whatever process we are applying on the data. Fine. Now I'm just closing this one, and afterwards there is one option save. So whatever activities we have done, we have removed one uh, attribute from the data. Okay. So I am saving the data because loaded data is there in the .csv format. Okay. So that is why I am just saving the data in the format which can be processed through the Weka. That is the ARFF format. So save it wherever you want to save. Just change the format of the data. I'm just giving bank1 dot ARFF. ARFF is the suitable file format for the Weka. Okay, that means processing will be easy if we have the .arff data. In earlier sessions, we have used ARFF in data sets. So today we loaded the CSV file, and now that CSV file we are converting or saving into the attribute relation file format, that is ARFF. Click save option. Now the second step of this particular data is, again, some numbers are there, like age numbers, or you can see the incomes. These are the numeric values, and we can just uh, we want to, for example, we want to apply some association rule in this data. Okay, so these two numeric attributes are not important. Okay, so that is why a discretization method we can apply here. So where is the discrete method? Filtering option, that is a discretization I want to apply. Where should I get this filter option, that is a discretization? Where should I get? Not a supervise here. Just we are trying to apply pre-processing algorithms. As discussed, that I have to convert the information. Okay, so classification clustering will give the categories, will give the classes, but I have to convert the data. So where should I get the filtering options, discretization option? Yes,
Hello, sir.
yes,
We go on Tuesday on top under filter.
yeah. Here,
Then we go.
here we will get.
Yes. Then we go to and then we go under filters. We go to unsupervised. That's where we find the script side.
Yes.
Items.
Under unsupervised, here we will get unsupervised. Here we will get the discretize. Okay. So now I just check the properties of this one. Some properties are there. We are not editing anything in this case. Just keep as it is. Fine. So here in our data, three attributes are there, like having some numeric values like income, the children's, the age. Okay, so that is why we are trying to apply the discretization. So it will convert. Now you can see income format is a numeric. Then age format is also numeric. So trying to apply the discrete and see the format is changed now. It is now nominal for the age. You can see I have selected the ages, and you can see the type is changed. You can see for the like income as well, and all the detail about the people's income, customers income are counted here with the nominal format. You can see the children's also, the format is a nominal. Okay. So I have just applied discretization. I hope you are doing parallelly. Then,
Yes.
so that the value we have replaced with nominals. Again, save the data. Now this is our pre-processed data. I'm just saving into the other file, that is a bank data 2. Again load the data, bank data 2. So see, the format is now changed. Whatever changed format is there, we have saved in the new file and loaded that newly saved file, and you can see the format is changed as per the requirement. Okay, now once again we can choose the filter option. We can select the discretize again to change the uh, numbers, sorry, nominals to the numbers. Okay, so this type of pre-processing we can do as per the data. Now we will try to check the missing values from the data. Okay, so how to check missing values? We have some options. First of all, I will edit this. You can see now the format is changed about all the data. All the data is there in the nominal format now. Right? You can see here all the data formats are changed here. Missing values, for example, I want to find out. Now the next target is to find out the missing values. So let's consider the region. No missing values are there. Or children. As discussed, there is a no need of this one. I'm just removing this one, region and nominal, region and children, because this information is not suitable for me, because I have to find out the option where customers are buying PEP or not. So yeah,
Mute yourself.
so I'm removing these two again. So here I want to find out the missing value. So again, there is an option which we have said. You can see somewhere we will get the missing values. So in this case, we can apply the function replace missing values. Replace missing values. Apply on the data. So wherever missing values are there, those missing values can be replaced. Okay, in a data somewhere some values can be not there, or some values will be missing. So in that case, replace missing filter will applied. You can see the data how we have replaced the missing values. Okay, see now the information about the data. So we are converting data into the suitable format for applying the further processing. Fine. So that is the pre-processing for this data. Now I should apply the other info methods. So first of all, we will try to apply the clustering methods. Okay, clustering methods, as we know, can be grouped with the similar patterns, or we will go for the classifier. Here, classifier, for example, you can get any classifier. Now let me know. I have just converted the data. We have removed some unwanted columns manually, right? Attributes we have deleted manually, like age, then the columns like income, children column. So those attributes we have deleted. Then we have converted data into the nominal format. We have checked the missing values and replaced accordingly. And data is converted into one suitable format, that is a nominal. Okay. Now let me know what type of classification algorithm we can apply here. Rule based, tree based, या meta classifier, bias theorem, bias classifiers.
Rep tree,
Which one?
rep tree, REP tree.
REP tree.
Stacking also.
Stacking also, yeah. So click on that. Properties, keep as it is. Use training set as it is, and automatically it will, as we know, automatically it will consider the last uh, option, that is a class option where classes are present. Now here only two classes are there. So the answer is not up to the mark, because you can see the incorrect classified instances are 30%. There is no supplied test data set. Here, with respect to the supplied test data, can you let me know how can we create now supplied test set? Can we create a test set data? Can we create a test set? So here we have seen this option, save as. So whatever information you want to add into that new data, we can use that data for testing purpose as well. Fine. Cross validation, by default, tenfold cross validation we will see here, and see it has not given again the correct output. Percent fill,
So why your output and mine output is different?
might be you have changed something. What is your output?
So the root relative squared error is 103. Yours is, I believe, it was 86.
This one.
Yeah, it's right. Yeah, this one.
Yours is a 86.
No, mine is 103. Yours were 88.5268.
Might be you have applied the other filtering method. That
No,
can be
sir,
the
I'm
possibility.
using the classify only.
I'm talking about this filtering method. So here, firstly, we loaded the data, then we have saved the data, and that saved data we have opened. On that open data, we have applied filtering options, and then we are trying to apply the classifier.
It's replace missing value, same as yours.
Okay.
Okay, I'll check. Okay, sir.
There is a possibility of using the different data, because two, three times we have loaded the data here, and some attributes we have deleted here also, and then some filtering options we have applied here also. So might be that is the problem. And then we'll try with the percent spill. Start it.
I'm also getting what she got.
So that means you have used the same data. Which one data might be
The second data you saved, sir, that
ha
bank data too you saved, right?
ha
The
that
same
means
one we have applied.
here you have applied, right,
Yes,
on
sir.
on this data, right?
Yeah, exactly.
Just a minute. So see, on that data you can see this age, income, and children. So these three informations are there that I have deleted. Getting my point?
Yes,
And that
sir.
is why it was giving the other output.
So you have removed age also?
Yes, the numerical values we have removed now. So I will show you for this data again. See, got it? See the output now,
Thank
87.
you, sir.
So that I have done, that columns I had deleted. So we were talking about the percentage split, and you can see the this option is also not given. This classifier is not given the correct output because the data format is a nominal, and the numeric columns we have deleted from the data. For example, here I will try to apply the J48 on a training set. Again, see only 76. Cross validation we will check. 64% spilled, 57, 60. That means on a nominal data, whatever algorithms we are trying to apply are not giving the correct output. Means they are giving the low output. Okay, so in this case, we will try with the clustering algorithm. So clustering
So is
algorithm,
there any big difference? Like we are getting, you got 99 point something, I got 97, that relative squared error. So is there any big difference?
this is the error now. Root
Yeah, that is
relative,
what I'm saying, sir.
this is the error. So error is more in this case. That means the output is not correct. And as I discussed, the kappa value must be near to 1. And see, the kappa value is only 0.21. Okay, that means output is
That is,
incorrect. Okay,
yeah. Yes, sir.
so choose the algorithm. So here, uh, Veka is providing 5 to 7 clustering algorithms like a cobweb, canopy, then farthest first, filtered cluster, then hierarchical clustering. Okay, then density based cluster, which uses wrapping, and here k-means cluster. So first of all, we will apply the canopy clustering algorithms, and we'll check whether that data, converted data, will give the correct performance or not. Now, now let me know which option I supposed to select here. Which use of training set or supply test or percent spill, or which one? Yes, classes to cluster. because that will give the correct output with respect to the last attribute. And see again, incorrectly clustered instances are 86%. And how many clusters have been generated? 39 different clusters have been generated. Clustered instances.
Sir, mine is 91%.
Might be you have used the different data. So that is I'm trying to say. You can check the attributes. Mine attributes are 8. Your attributes may be more.
So mine is also 8.
On which data? On this one, right?
Yeah, exactly, sir. Canopy may. I got cluster 0, yes, and cluster 6 is no, and all are no class. And total 49 clustered instances.
With 8 attributes.
Exactly, sir. 8 attributes only.
Okay. How many attribute clusters you obtain? 39 or 40?
49, sir.
49. Okay, here we are getting the 30. Let me check with the cobweb. That means the converted information in the nominal format is not suitable. So that will be suitable for the associate rule. Getting my point? So
Yes, sir.
these algorithms are giving the incorrect output because we have converted the information, the attributes into the nominal formats. You can see here. And the clustering algorithms, classifying algorithms works with mathematics, statistics, right? So they'll require some numeric values. So that can be the reason of not getting the correct output.
Sir, you removed income, right?
Yeah.
That is the thing. Yeah, I removed actually reason,
No,
but
no,
I
no, no,
have
no.
income.
No, no,
That's
no.
why.
You have that means you are working with numeric data. So that is why I am telling now.
Yeah,
Might be your
exactly.
data is different. That is why the output is different. So associate rule a
So
priori. Hmm?
income will be there, sir, right? And
Income,
reason I forgot.
income,
Income
age.
removed, reason should be there.
Yes, the numeric columns. Try to remove it.
Okay, so reason.
So here associate rules, association rules we can apply. For example, a priori algorithm. So it generates some dependencies. Some values are there. Keeping as it is. Start. Best rule. No best rule has been selected. because see the relationship with the different attributes. Keeping point 4. So with a minimum point 4, right? So here I have changed this one. So minimum metric in earlier case it was zero point 0.9, and now I have just changed. Then associate rules have been created. So as discussed that associate rules requires two parameter if then, right? Save act, if save act is there, then current account. Saving account is yes, then current account is also yes. So these are the relationships between these two properties. Second one is the motic. No. If no, current account is yes. Okay, that means user is having the information. Does the user have the mortgage? No. That means he is having the current account. Whether he is a married, yes. Current account is also yes. So such type of association we can create through the nominal data. Then mortgage is no, saving account is yes. So here in this case, current account was also yes. If saving account is yes, then might be the customer is a married. So likewise, a relationship we can create through this one. Okay, here one more method is there, filter associator. So I have not changed the value here. Class in seed, for example, 10. And
So
the,
can you repeat, please?
yeah,
So what are it?
I'm just trying to create association between these two. Okay,
No,
because
sir, the changes what you have done in that filtered associator.
here I have just changed the seed value. It was previously one, and now I have changed it. Okay,
Yes, sir.
so for some sets of items, sets of large item sets have been generated, but the rules are not generated by the filter associator because a priori algorithm is suitable in that case. Here, this is giving the incorrect because in minimum input where is that option? Let's consider here.
Sorry, sir. I didn't get where you the option to open that dialog box which you are opening right now.
Which one? This one. I have just
It's more dialog box, yes.
selected this filter associator. Here, just click on this one. Okay, and now you can see the rule, associator rule, a priori by default it will be applicable to the filter associator also. So here a minimum metric we need to apply, that is zero point 0.4, and a minimum number of rules, if you want to change it, you can change it also. So number of rules are 10. Those are the by default numbers. Okay, by default 10 rules we can create. So I'm changing with 5 rules. So I will get only 5 rules through this method. So here you will get the information about this minimum metric. It was zero point 0.9. Okay, so this value was zero point 0.9 in our first step. And now I have changed. In that case only it has given the output. Okay, so see, before it there were no rules generated by the filtered associator, and we have changed the minimum metric and the rules, minimum rules. Now see, the model is associator model. A priori algorithm is by default applied there. Minimum support, we have given minimum metric confidence was given zero point 0.4 only instead of zero point 0.9. Okay, and how many times the cycle has performed? 11 times cycle has performed to get the 5 best rules. Okay, saving account is yes, then current account is also yes. So likewise, some rules we can apply. Okay, one file format we have converted, data is changed and applied the association rules now. So we'll take a break for 5 minutes and then we will go for the other data with other methods, or same data with other methods. Okay,
Sir, can you please show your screen that associator output?
I have added only 5 number there, so that is why I got 5 rules.
Sir, I'm getting 10 rows.
So you have not changed the number now. So that I was telling. Here you have to change it. Minimum number I have given 5. Here.
Many metrics also. 4.
So that is why I am getting 5. Might be you have not changed this number. Where you will get this number? Under this
Okay, sir,
upper.
got it.
Okay. So we will take a break for 5 minutes and then we will continue with the next task.
Yes.
Okay, welcome back again. So we will go for the another task. Let me check any question if it is there. Kanchan ma'am is asking the question that is how you save .csv file in a Weka folder. Please say that first part, please. Okay. So very simple. Only one option we have to apply here. You can see here in a P process, whatever data you have loaded here, just try to save here, and you can see the file types. Too many file types are there. Okay, according to that file format, just change the format. That's it. So previously it was in the .csv, and I have given .arff. That's it. Did you get it? Now one more time I will try to load the data. So this first data where we eliminated only one attribute, only one attribute we have deleted, that is the number. It was the unique number, ID number we have deleted, and that data we have saved. So here we will try to apply the pre-processing algorithms like feature selection. You can see 11 features are there, but directly all features we were giving to the model, to the associate rules, right? But now from these attributes we will check how many attributes are important. So accordingly we will select the model. Okay, so first of all we are trying to apply the classifier algorithm as it is on the data. So I am just deleting these buffers from the memory because it will consume some memory. Before applying any pre-processing algorithm, because here you can see the data is in the numeric and nominal format, but no missing values are there. You can visually also you can see here no missing values are there in the data. Okay, so data is a little bit perfect. That is why the filtering option I am not applying now. And in the original data you can see 11 attributes are there. So on 11 and on with 600 instances, here you can apply for example any one of the algorithm. First of all I will use any one of the algorithm, but let me know in this data nominal information is present, numeric information is present. So which algorithm, which supervised algorithm classifier I supposed to apply? Are you hearing me?
Nav base.
Navibase, yeah, that can be applied, but conditions are there in the data, predictions are there in the data, probability is required in the data. Okay, so first of all we'll try with this one, training set 65, because as discussed that Navibase works well with the data where conditions are required, conditions are there. According to the conditions it works very well. And this algorithm we have applied on the 11 features: cross validation, tenfold, again 65% field, 65. All the three options have been given only 65% accuracy. Okay, that means this algorithm is not suitable because in the data predictions, or you can say the information related to yes or no, or you can say the information or the conditions are not there. Conditions are not required. That is why this algorithm is giving low output. Now, second algorithm we will apply here. Bias
So we
thread.
are applying with 11 attributes, the first one.
Yes. All we are trying with the 11 attributes, and all three options, training, cross validation, percent fields, are giving the similar output. You can see here 11 attributes are there, and still accuracy is
So
not
we
up to
can
the.
apply decision table.
Yeah, decision tree or decision table we can apply.
Right. Decision table. Rules.
Yes,
Uh, yes.
82%. Best first method is applied here through the decision table, and decision table
81%.
works with the best first algorithm. You can see here search algorithm is best first. You can apply the other also, either best first, greedy stepwise, or ranker according to the rank, according to the best first. So whatever by default it is the best first, so whatever we are providing accordingly it will provide the output. Okay, now we'll check with the cross validation. 80%, and for the training set it is 82%. Percents field
77%.
75% only. That
The
means
77% for cross validation and use training 82.5. More than one. Like yours is 81.5, mine one is 82.5.
Yes, 77%.
77 here might be your percent field is a 66. I have changed with the 80.
The mine is also 80
What?
by default.
Check the values. Have you changed anything? If
Nothing, sir.
if we change something, so it will give the different
Yeah.
outcome.
74%. 20.
75, 80, 82.
Yes. On my percentage split 66 and result is 74.
So how
The
to analyze the
percentage
result?
split is 75.6.
Analyzing the summary is very important if you are trying to gain some insight from the data. If you want to write some reports, or if you are trying to write some research papers, so analyzing this information is very important because right now people are using deep learning, reinforcement learning algorithms on real-time data, and they are getting accuracy near to 99%. Then why should we apply decision table, decision tree with only 82, 85% or 90% accuracy? Okay, getting my point? Because other methods are giving 99% accuracies. And why I suppose to apply these traditional methods because they are giving the low output. Okay, so in this case, remember that so whatever algorithms, advanced algorithms are there, they'll require the high complex data, and their parameters, required parameters are also more, and their required system configuration are also more. These traditional methods can use little bit of memory, then it works well with the limited system with limited RAM. Okay, and on this particular information, we have to build such type of model which can give the nearer results related to the deep learning or other advanced methods. Getting my point? With these methods, we have to find out such type of a model. We have to build model which gives the results near to 99 or 98%, or in some cases 100% also. So that is our target, because the other method, advanced methods, I'm talking about it. Advanced methods can be implemented with or you can say the required system setup for advanced methods is high. So RAM is required more, the processor required more, size of the graphics card or other information is required more. Okay, and the time taken by the algorithms, deep learning algorithms, will also be more. That is why, and here our models are giving results within a second. You can see within a second we are getting the results, and other models like advanced models are giving 100% results, but their training timing, testing timings are too much. Some deep learning models took time in hour, and here we are talking about minute or second. And with this uh, methodology, we have to find out such type of solution which can give the either you can say a satisfactory output. Okay, so that is why we are trying to build such type of model with a different uh, parameters. Because let's consider I don't have such type of system which is suitable for advanced computing. So why should I stop? Then I will apply the other strategy. I will train my own models, different models. I will apply different parameters, and I will check and validate my result. So validation of result is very important. So in this case, we will build model which can give the good result, and then we can go for it. For example, here bagging meta classifier. I am trying to use bagging on a training set. Now see the accuracy is enhanced through the bagging. Cross validation I am trying 91 again, percent split 90, and percent split for example 80. You can change any information. So this bagging algorithm is also giving the 91% accuracy. So I will try with other algorithm. So let's consider this J48 90 again, cross validation 89 92. Random forest. And now see my output. How much percent it is? 100% on a training set. Cross validation. Training set means the same data we are trying to use for testing also. Cross validation 88%, and percent split 90%. Here we can change the information of the model, how many iterations we want. 100 iterations by default, iterations are 100. So these parameters we can change, and we can check the output also. For example, seed value, now I am changing with the 2. '89, 88, 100%. So that means the selected seed value is also not applicable. Trying to give the set with a 10. And see, this random forest algorithm is also taking some time to run it. 0.01 second.
100%.
Yeah.
Yes. And it's incorrectly classified as 0.
100% correct means 0% are incorrect.
Correctly 100% and incorrectly 0.
Oh, that is the correct output.
Yeah.
Multi-class classifier not applicable. Okay, so the other algorithms are not giving the suitable output. So that is why I'm deleting from the memory. So the information is on the 11 features. Now we will try to reduce the size of features, and then we will try to get the output through the same models. So where to select the models, the features here. So we can apply any one of the feature selection method here.
Hello.
Yeah.
Hello, sir.
Yes.
Yeah, I am having challenges with the audio. I can't hear anything. It's jumping. I can hear this part, and if we lose part of it, I don't know if something can be done.
See, here we tried some models. So we are now in the conclusion that random forest and the decision tree algorithms meta classifiers are giving correct outputs. I mean the satisfactory output. So on 11 attributes, we are trying to apply these models. Okay, now we are selecting the features, best features, and then we will try the output through the models. First of all, we will see the correlation attribute, ranker 1. Okay, so it has given 10 features. That means as it is, it has given the 10 features. threshold value and all. Okay, gain attribute, again 10 features, info gain 10 features, because in the data total 11 are there, and the algorithms are giving the 10. Okay, principal component. Greedy stepwise method with a wrapper subset we have applied. Okay, all methods we are trying to check it like whether they are giving same 10 attributes or less attributes.
Sir, use second classifier video.
Is classifier,
Second.
here classifier attribute. So again, this is also giving the 10 attributes. That means in our data we are having 11 attributes, so the first 10 are the attributes and last one is also attribute, but in this attribute we are having the final classes. So all methods are giving the same output. So here I am trying to use the classifier. Again, it has also given the 10. So now classifier attribute evaluator algorithm has given 9 attributes. Children,
So
age,
what you have
income.
changed in your ranker?
Here I have changed the folds. I have applied the Navy base algorithm, and I have applied here values to be ignored. How many attributes I supposed to ignore? I just given 5, and in this case I got the output with a 9. That means all features are needed. Okay, so we can apply the clustering. Here I'm just removing the others. Simple k means clustering I'm applying here. And in this case, how many minimum clusters I want? Yeah, two clusters I want, because in my data I want output in a yes or no. Okay, so number of clusters are also two. uh, the other information I'm keeping as it is, even though the distance algorithm you can change here. If your current algorithm is not giving the correct answer, then we can try with the other algorithms. Seed value, the random number, seed value must be 10, keep as it is. Group was first cluster is saying yes, second is saying no, but their incorrectness is too much. 43% incorrectness is there. Filtered cluster I am applying. Same. So the data is labeled. Okay, so then there is no need to apply clustering algorithms, because they are not giving the correct answer. Even though we have the good classifiers for this data, because this data is having label values, and they are also giving the good outcomes near to 90, 88, 90, 100%, 92%. So in this case, we can go with the classification models. Now you can see the visualization of the attributes with respect to different parameters. You can select here, just click the particular attribute, and we can save it, whatever file name you want to give as per the information. We can just check change the information here to the jitter, how many instances in what format you want. A rectangle, for example. Now you can see the rectangle color for the last attribute xy. So that can be like we can change here. Hope so you are getting some insights from this particular demonstration. So one data with a high information I am adding here. So this is one of the cloud based data. Okay, in this data, sorry, the information about network attacks are given. Training data, I am having training data as well as I am having testing data. So whatever model we are trying to train, through the testing data we can check the validity of the model. So as discussed, whatever data you are having, you can also generate some data, clear data for testing purposes. So you can check the validity of your models, right? So this data I have downloaded from the website. On that day I have shared the a screen and shown that one particular website, right? Through that website I have taken this data. And now see, for example, I'm loading this one. Okay, see the parameters. Instances are 35,000. Attributes, I mean columns, filters, sorry, features are 231. Means 231 columns are there. And some data you can see missing values in a first column only. 99% values are missing. You can visualize through edit also. See, first first column don't have any value, or some in some cases zero values are there. Now you can see this information missing value. You can see whenever I'm moving my cursor here, so it is just giving the uh, real-time analysis. So whatever data sets we were using, so those were having limited values, limited instances, limited attributes. And this is the real-time data, near real-time data, which is created by uh, the Canadian Institute for checking the cyber attacks. Okay, because nowadays we are using network, internet-based data, and we are sharing some information. So some attackers are trying to attack on such type of data. So that is why they have created this data set where they have uh, artificially added some attacks, and through this data we can build our model, and in a real time that built model can be used to detect the cyber attacks, and accordingly we can monitor the cyber attacks. So that is why this data was generated. Okay, so KDD99 data set name is there. So that data is having some missing values, null values. So here we have to apply the filtering methods. So here too many filtering methods are there. Discretization, then the missing value, normalization. Normalization means the value, all values from the file will be normalized, equally distributed. I replace missing value, we can apply this one. Okay, you can check here. Too many missing values are there. And in the final column, two classes are there, yes or no. So this is having the highest value, that is normal, and this is the attacked information. Only limited values are there where attack have been happened, and we have to check those attacks through our model. So first very important step is that normal removing the missing values, then removing the null values or zero values, then replacing the missing values, and then replacing the missing values, and after that we can apply normalization. So data will be normalized, and then selection of features, because here 231 features are there, and if we consider all 231, so it will take too much time to train the model, and even though we will not get the correct output, because in all the attributes some information is not correct. So let's consider one simple algorithm we will apply here. That is one famous algorithm which I prefer for my analysis. So that I am applying here. See now, it has started. You can see the status at the bottom, left bottom, status building model on a training data. Now see the timings taken by the data. At a left bottom, you can see the status. The model is started to built on the training data. So this raw data we have given, we have not pre-processed the data. Now see again the status is this one. So I will share this data on the group as well. So let me share the attendance now. Nilesh, why are you leaving again and again?
My internet problem, sir. My router is damaged.
Okay, see,
That's why.
still the model is trying to build on the given data. So that is why now see model is taking too much time. That is why selecting the features and removing the unwanted information from the raw data is very important. And now see whatever output we will get through this model, it will give the incorrect information because all the instances, all attributes as it is we have given. Uh, till time, whatever questions are there, you can ask. If you have question, then you can ask.
Sir, can you one day practice on real data and
Hmm?
make any report? Yeah, like
Can we?
practice on real data
Yeah,
and make a report.
this is one of the real time data. I will share on the group. Don't worry. And see,
But you have teach us how to make research report. Like,
see, you have to take a problem firstly. What is the problem? Why you want to write the paper on that problem? So accordingly, you have to find out the data. If data is there, you have to learn about the data. What is exactly there in the data? What are the values there in the data? And the relevant information. Fine. And then we can try to build some machine learning or ensemble learning models through Veka, and then you can analyze this one and you can write the paper there. And see, J48 algorithm has given 98% accuracy on the same data. And see here, the error. F1 score is not generated. Here you can see the error. Still output is 98%. That means whatever model we are applying on the raw data, no matter what type of output it is giving, but if you see here this F1 score or precision and the information about the error, so that means the model is completely giving the wrong output. Still accuracy is 100%, near 100%, but the output is not valid. Okay, that is the main point here. And you can see the time taken by the model, 182 seconds. That means near about 3 to 4 minutes. And for testing purpose, only 20 second, 12 second, 0.12 second. And in earlier case, you can see the F1 score and all. You can see classes also. All the values are there, but this algorithm has given wrong output because raw data as it is we have given to the model. So number of values are there, those all values are not suitable at all because missing values were there. And see here, same data we have supplied. For example, here we will use the cross validation. Again, it will take some time. Session is open for question answering. So take any one of the project, real-time project, get the data, get the problem. Firstly, understood the data, and then try to build the model. Without understanding the data, don't apply the model because see now here the data is incorrect because that data is raw and still we are getting 98% accuracy. That means it is completely wrong. If we are getting 100% accuracy, that doesn't mean we are getting the correct output. We need to validate our output and then we can analyze it. Analysis of the output, analysis of the data, analysis of the models, and the results are very important in a research paper or in a report writing. So we'll see the output and then we will stop here. If you have the question, just let me know.
Thank you, sir.
Yeah, thank you so much for joining us. Uh, Today or tomorrow, we will provide you the examination link. So there you have to do some practicals and you have to upload your answers. So accordingly, the organizer will evaluate the assignments and the final examination. Okay, and accordingly,
Sir, please send attendance link in WhatsApp group.
sorry.
Sir, please send attendance link in WhatsApp group.
Okay, okay.
Okay, thank you. What time should we expect the exam?
Exam, sufficient time will be given for the examination because we are trying to give the question based on practicals. We'll give some data. Okay, already I have shared the data, and we will give some task to do that, and accordingly you have to submit your practicals, your snapshots, whatever we are getting through the assignment link.
Okay.
Okay,
Yes, sir. Okay, thank you.
Sufficient time will be given. Do not worry about the time.
Thank you, sir.
See now the output is getting 166 seconds to build the model on the raw data. Okay, if no questions, we can
No, sir.
stop here. Thank you
Yeah.
so much for joining us. Hope so. Some of the sessions are important. Might be some knowledge you have gained through this one.
Awesome session, sir.
Thank you so much.
Yeah.